Now, the world of AI models is moving along at an incredible speed. Every day there's something new and something interesting. Well, Google just released something new and something interesting, DiffusionGemma. It takes the ideas from diffusion models and the ideas from large language models and combines them together. So if you want to find out more, please let me explain. Okay, so let's jump into this then. So what's the problem? So current LLMs, they're called auto-regressive, that's a technical term for them. They generate the responses token by token, serially, one after the other. And every time you want to generate a token, you activate the entire neural network until you get a token out the end. Now, local single user inference underutilizes today's powerful GPUs. In fact, if you use software like VLLM, you can actually serve multiple requests at the same time and get similar performance. And I went into that when I was looking at the Jetson Thor, if you're interested in that kind of thing. But basically, half of the GPU is laying around doing nothing while the network is being progressed through to the end. So this high latency hurts interaction because we're always trying to go for more tokens per second. So if we can use the GPUs better and we can improve the speed, then this could be an interesting solution to these problems. So what is DiffusionGemma? Well, it's built on Gemma 4 26 billion. That's the 26 billion mixture of experts version of the different Gemma 4 variants of the model. And that version, because it's a mixture of experts, has basically 4 billion parameters, 3.8 billion parameters active at any one time because of the different experts. So they take that model and then they add in this diffusion research to give us this text diffusion model. So before we talk about text diffusion, we need to understand what is AI diffusion. Now, you've seen it in operation. Every time you've asked an AI model to generate an image, this is what's been using. So the core concept is that it creates data by starting from noise and then progressively refining it into meaningful content. So during the training process, the models start with meaningful content, let's say an image, and they add noise to it all the time until you end up with noise. And the reverse process is, because it's learned that now in the training, the reverse process is you take away the noise one little bit at a time until you get to some meaningful content. So it's an iterative process that goes from noise through to meaningful content. So text diffusion is exactly the same idea. In this particular case, you start with 256 tokens in a kind of a canvas, and then you start with random tokens in all of those places, and then you go around in an iterative fashion, changing those tokens, going through the diffusion process until you get meaningful content. And you're doing that 256 tokens at a time. So each iteration actually works on 256 tokens. If you don't need 256 iterations, let's say you need less than that, 6 or 7, then now you've got a massive speed increase because you've gone from no tokens, no answer, to an answer of 256 tokens long in only 7 iterations. So here's an example of that. The rubbish tokens might be it, flamingo, hi, really, camera, bees, never. Doesn't mean anything. And then slowly it goes through each iteration, changing them. And as you get down here to the lighter grey ones, B, LLM, pick words all at, exclamation, and LLM picks words all at once. The LLM picks words all at once. So that's the final output. Having gone through these different iterations where it removes noise and picks a better token for each slot. And that means it's fast. So you're changing the bottleneck from being memory bandwidth, where you're dealing with that whole model every single time, no matter how many gigabytes it is, has to be processed every single time. Now you're moving that away to compute power, because basically you're doing 256 at a time. So there's some parallelization going on here, which means it better utilizes the GPU tensor cores for massive parallel output. And Google are saying that on a H100 system, you're going to get 1,000 tokens a second. On a 5090, you're going to get 700 tokens a second. Now, of course, those are massive increases than what we're seeing right now, maybe even 10 times faster or more what we're seeing now on the same hardware. Okay, that's enough theory. Now it's time to show you a demo, but before that, a quick word from the sponsor of today's video. Now, every day we're all uploading files to the internet, photos, documents, video clips, and so on. Now, once they leave our computer and they arrive up there in the cloud, who has access to them? Who controls them? Now, I'm not saying that if I take a few photos of my dog playing in the park and they get uploaded to the cloud, that's a problem. Fine. But let's think a bit deeper. Let's say I went to the doctor's and I had some tests done and I got the results in a PDF file, for example, and I copy that into a folder that gets automatically backed up into the cloud. Who now has access to my medical data? That is a really important question. Not only who has access to it, but are my files being used, for example, as AI training data? I don't know. Now, I'd like to thank Mega for sponsoring this video. Now, Mega is different. Mega is a privacy-focused cloud storage and security platform with over 300 million registered users. It uses zero-knowledge encryption. That means, first of all the data on your device is encrypted before it leaves your device. And then once it arrives in the cloud, because of this zero-knowledge system that they use, no one at the other end can decode it. Only I can decode it. Now, Mega is a true all-in-one privacy-focused cloud storage and security platform. Not only does it offer cloud storage, but you also get a password manager and a VPN all built in. Now, here's a really interesting thing. All of the client-side apps for Mega are open source. So the Android app, open source. The desktop app, open source. You get the idea. Completely open source. Now, what this all means is that there's no backdoors in Mega and no third-party access to anybody else. Now, for me, that means if I do have things like medical files or maybe legal papers, then I can securely back them up there, knowing that they are only for my eyes and not for anybody else's. Use the link in the description to get 50% off. What that means in real terms is that for $4.50 you get 3 terabytes of storage, 3 terabytes of storage, you get VPN access and you get that password manager, and I'm sure that's less than what you're paying right now. Or if you want to just give it a try, there is a free tier where you get 20 gigabytes of storage. Okay, now back to the video. Now, to get this running, I had to rent a cloud GPU instance on the internet because nothing I had locally could run. You need 60 gigs of memory in your graphics card to run this. Now, that's because it's not a quantized model, it's a full 16-bit model, I think it is. So I just didn't have the hardware for that. Now, there may be quantized ones around. I couldn't find one at the time of making this video, but if there was a quantized one, then I would have been able to run this locally. But for this one, I had to have one up in the cloud. However, as you'll see, it worked quite well. Okay, so now I'll actually take it for a test drive. So our first question, Alice has 5 brothers, she has 3 sisters. How many sisters does Alice's brother have? Let's see what it says. Alice's brother has 4 sisters, which is correct. You have 2 hourglasses, one that measures exactly 7 minutes, another that measures exactly 11 minutes. Using only these 2 hourglasses, how can you measure 15 minutes? Okay, so it's given quite a lot of output. The last bit here I think is correct. It's not the best way to do it, but it is a correct answer, so that's good. Now here's a more difficult one. Let's see whether it gets it right. Start with 4 upright empty glasses. You must invert exactly 3 glasses in a single move. Can you invert all 4 glasses in a minimum number of moves? And it's come back, and what's it said? Here's the logical breakdown. No, it is not possible. The answer is no, it is not possible to invert all 4 glasses under these constraints. Well, you can do it in 4 moves. So it does get some things wrong. Now, what's interesting is that the normal 26 billion parameter Gemma 4 model can actually answer that question. And I think a lot of it's to do with the thinking process. With a normal auto-regressive LLM, you get all those, paragraphs of thinking. You don't get that with the diffusion model, and therefore I think it just leaps to the wrong conclusion. So another disadvantage of this system is that the input isn't very long. So if you ask it a longer question, in a certain flower garden, each flower is either red, yellow or blue, and all 3 colors are represented, and then it gives you this logic puzzle. But the important thing is that when you send that across, it says, this sounds like the beginning of a logic problem. Since you haven't asked a specific question yet, I can help you complete the scenario or solve a problem based on it. And then it starts to go on because it hasn't really read the whole problem, because I think it gets truncated because of this diffusion method. It's different to the sequential method, as it were, that we're used to. So for longer inputs, it can't give you the right answer. And let's just see what its knowledge is like. This, of course, doesn't search the internet, so this is only what it knows. What was Paris like in 1849? Let's see what it says. Okay, so it's come up with quite a nice answer. It's got some good text here. Now, you can start to argue about its style and some of the things it's saying. So, for example, if we look at this here, Victor Hugo was writing Les Miserables, published in 1862. So, no, he wasn't actually writing it at that point. It's way too early, 1849 to 1862, and it didn't take him that long to write it. However, of course, he was obviously alive and experiencing things. So, again, it depends on how you want to express things. Maybe they could be more nuanced, but the good thing is it is able to give us quite a deep recollection of some facts. Remember, this didn't go on the internet. This just said what it knew from its own stored memory during the training process. So overall, the problem seemed to be this. There's a chopped input because you've got this input processing of this diffusion idea, so longer prompts don't seem to work. You've got the problem that the output is limited. Now, I configured mine to have a maximum output of 2048 tokens. In fact, Google say you should have 512 tokens in their demo code. So, of course, it's always going to be truncated output, and that can cause a problem. On a auto-regression LLM, we're used to, if you want 1,000 words, that's what you're going to get because you ask for it. And then that leads also to the thinking output. With a normal traditional LLM, you get all these paragraphs and paragraphs of thinking. You're not getting that. So the limited output means limited thinking, which means it doesn't always get the right answer in the most difficult of situations. Now, at the moment, this is an experiment from Google, a research project, and it will be interesting to see whether Google are able to take this further, because obviously being able to generate responses with less GPU power or less compute power, being able to do it quicker, are the things that we need the most now in this ever expanding time of AI models. Do love to hear what you think about this in the comments below. Do drop a comment to tell me whether you think a change in direction, something like this, is what we need now because we've come to the limit of what we can do with current large language models, or do you just think it's just going to be bigger and better and bigger and better and go down that path? Love to hear your thoughts. Okay, that's it. My name's Gary Sims. This is Gary Explains. I hope you enjoyed this video. If you did, please do give it a thumbs up. If you like these kind of videos, I invite you to stick around by subscribing to the channel. Okay, that's it. I'll see you in the next one.